the last thing we'll look at here in Chapter 9 about buffers is how would we actually make a buffer. Now we can go through, usually we want a buffer with a specific pH. So we could go through the Henderson-Hasselbalch equation and calculate things to figure out, okay, we need exactly this many moles of, conjugate acid A and conjugate base B. But what is in practice, what we usually do instead is we make a mixture of our conjugate acid and base that's close to the pH we want. Often maybe we'll start with equal moles or whatever. And then we would adjust it use a strong acid or strong base to adjust the pH up or down. So the reason we do this is that even if we go through the trouble of calculating what exact amounts we'd want, we're neglecting some effects that are going to lead to some slight errors in our final calculation of the pH. Specifically, we're ignoring activities, that's a big deal. And because we may have other things present in our buffer that change the ionic strength, and possibly temperature effects and other things. So it's much easier to just make a buffer that's kind of close to what we want and then just use strong acid or base to change the pH up or down. So for example, maybe we add, and often we'll start with just one or the other, right? Rather than starting with conjugate acid and base, we usually just want to measure out one chemical. So let's just, as an example, let's say we're making a tris buffer. We add about 0.1 moles of a salt of tris. So tris HCl, that's a chloride salt of tris H+. Say we want to make 1 liter. So we add it to about 800 milliliters of H2O. Maybe this is in a volumetric flask, just not filled up all the way. And then we will measure the pH. So using something like an electrode. Electrode work best here because we want to be able to monitor the pH as we change this. And so hopefully this moves. There it goes. Moved too far. All right. We measure the pH. And here we can add a strong base. So maybe we add a sodium hydroxide solution to adjust the pH. And we add it until our pH is, I don't know, say we want a buffer at 7.6. So we add sodium hydroxide until we're at 7.6. Then we transfer this solution to a volumetric flask if it wasn't already in it, and dilute and mix. So in practice, actually making a buffer, we'll usually start with just one of either the strong conjugate acid or conjugate base, and then change the pH using a strong acid or strong base, rather than trying to measure out, oh, we need exactly this much of this one and this much of the other. So we won't make any buffers in this class. We'll make them as we do acid-base titrations, but we don't need to. We do use a buffer for one experiment. The EDTA titration needs to be buffered, but that buffer's been made for you. But if we were needing to make a buffer, this is how we do this. And if you take biochemistry, I think you'll get the chance to make buffers in that class and use them. So so this is the end of Chapter 9, and I hope you have enjoyed learning about acids and bases.